So how far can we go with this? Well, you can imagine having more complex rules with more conditions in them. And you can also imagine having a whole set of rules, and your classifier now becomes checking this whole set of rules to determine the class. Okay. So how do we go about building an appropriate set of rules to come up with a classifier? Well, so one approach is this sequential covering, which looks like this. You start off with a data set D, and you initialize the rule set R to be empty, and you say for each class, say survived or not survived, you can construct one rule that correctly classifies some instances in D, right? So you capture some of the people who survived, and does not incorrectly classify any of the other classes. Okay, and then you add that rule to the rule set and remove from D all the instances that were correctly classified by this rule. And so we're going to keep on adding up rules this way. Now, that's great, but it doesn't tell you how to actually find that next rule. And so that's what this explains. So come up with a set with an initial rule R that just trivially assigns a class value to every record. Okay. And so while it incorrectly classifies some of the non-C instances in D, so write R as the antecedent of R determines C. And so here the antecedent initially is nothing. Okay. And then for each attribute value pair A equals V, where A is one of the attributes and V is some value of that attribute, figure out the accuracy of that rule, just like females predict survival, and we determine the accuracy there with 79%, or male determines, well, we're just dealing with one class right now, so just survival. Fine. And then figure out the attribute value pair that has the maximum accuracy over D. Okay, and in case of a tie, choose the one that covers more cases. All right, so now update the rule R with this new condition, A star equals V star, and remove that attribute from consideration in the set A. Okay, and then keep going until you are no longer incorrectly classifying some of the non-C attribute instances of D. And now in the next time around the loop, antecedent of R will be the previous condition. And so that's what this notation is just trying to show, so you can have the prefix of the rule and keep adding one more conjunction, one more condition, I should say, one more equality condition to the rule one by one. Okay. But the point here is that you're still looking for the attribute value pair that has the maximum accuracy. Okay. Okay, so in this case we started from an empty rule and we incrementally added constraints until we started incorrectly classifying some negative examples. But you can do it both ways. So there's a couple different strategies here. One is to go from general to specific, as we just did, which is start with the empty rule and add constraints to eliminate negative examples and stop only when all you have left are positives. But you could also imagine going specific to general, which is starting with a particular instance and constructing a rule that exactly specifies that particular instance, right? So it has a constraint for every attribute and uniquely describes that one data point. And then you could remove conditions one by one in order to try to cover more positive examples, and stop whenever you hit one that covers some negative examples. Okay, and then you move on to the next rule. Okay, so once you have these sets of rules, you need to use them to make predictions. And one thing that can happen is you can have more than one rule triggered for a particular data point. And so you need to have some way of resolving conflicts. So here you might choose the most specific rule, or you might even choose the most general rule, or you could apply some domain knowledge in order to assign a priority to each rule and use that to, break ties. All right. So a recap of this brief introduction to sort of rule-based methods is the representation here is a set of these if-then rules with varying numbers of conditions. Okay, and the evaluation strategy is to come up with the coverage of a rule and measure the accuracy by the number of correct predictions it makes divided by that coverage. And then the optimization is the search strategy is to sort of build rules by finding conditions that maximize accuracy one step at a time. And there you can either go from general to specific or to specific to general. And we didn't discuss sort of the various trade-offs among those choices. And so the maybe takeaway for these rule-based methods, besides using it to build into the next segment, is that, you know, one rule or just a few rules is pretty straightforward and pretty easy to interpret. A big set of rules may not be, right? The overall properties of a big pile of rules is not immediately obvious.